So ladies and gentlemen, we're going to dive into the start of chapter 6. So we have angles and their measures, and where we're going with this stuff is we're going to be doing right triangle trig of 30, 60, 90s, and 45, 45, 90s on a unit circle. So that's going to be in a rectangular coordinate system. We got to be able to draw angles. So that's one of the first things we're going to be doing today is talking about how to draw an angle. Once we know how to do that, then we can start converting from degrees to radians, radians to degrees, goal number 1. And eventually at the very end, we'll talk about arc length of a circle and finding the area of a sector of a circle. Okay. So first things first, let's be able to draw these out. This will be pretty easy for you guys. So as an angle theta is said to be in standard form if its vertex is right there on the origin, okay, of a rectangular coordinate system, and its initial side coincides with the positive x-axis. So this guy right here is the positive x-axis. This is what we call the initial side. So that guy always stays. That's where it starts initially, right? Well, then this side is the side that's going to be moving. We call this the terminal side. And this thing can go clockwise or counterclockwise, okay? Well, if it goes this way, so counterclockwise, then we're going to get a positive angle. So if I'm going this way, that'll be counterclockwise. If we go down, that's clockwise. You guys will see that that's a negative angle. Okay, so we have this guy's our initial side. That's going to be right there every time if it's in standard form. So I'm going to go through and just draw all of my initial sides in all 4 of these. And you can too, so go ahead and draw these out right here. And then we want to go through and draw a 60-degree angle. Now you don't need to bust out a protractor, it's just an estimate, okay? So what quadrant are we going to be in for 60 degrees? Quadrants 1, 2, 3, or 4, and I'm getting the finger, right? Kylie's giving me the finger, the index finger, right? She's saying 1, that's quadrant 1. And here's 0, here's 90. Is it going to be closer to 0 degrees or 90 degrees? Which one? We're going to be closer to 90. So right in the middle would be 45. So it's a little bit past middle. So it'll be right there. So if I'm going to show that work on a quiz or test, I would show a little angle in the direction I'm going. So in this case, counterclockwise, and then just show that it's a 60-degree angle. Okay, and it's an approximation. It's not going to be perfect, but it should definitely be closer to 90 than it is to 0. Okay. All right, so I do the next one. I got 150. What quadrant is 150 at? What do you think? Alex Young, where's 150?
The second one.
The second one. Again, this is 90, and then 180 is a straight line across. So I'm going to be in quadrant number 2. Am I going to be closer to 90 or 180? 180. So I'm going to just draw a little terminal side closer to 180 than it is to 90. And there we go. I got 150. So again, we're going counterclockwise. We're in quadrant number 2. That's easy peasy, right? And then 2 hundo is just a little bit past 180, right? So here's 180. Here's 2 hundo. That's going to be pretty close to a 180 marker. Just 20 degrees past. And that puts us in that quadrant 3. Last but not least, we got a negative angle. We got negative 45. Where does that put me? Isabel? Yeah, the 4th quadrant. Remember, negative is going down. It's yelling timber. You better move. You better dance. Hashtag Kesha. We're going clockwise. We're going down. Anytime you do negative, it goes down. It goes clockwise. So negative 45 would be smack dab in the middle. Okay. You guys have any questions? All right. So we're going to be working with 2 different types of angles. One is going to be in degrees, super, super easy, 0 to 360. And the other one's going to be in radians. Okay, when you ask, like, what in the world is a radian? Well, first things first, we got to know what a unit circle is. A unit circle is a circle where you have a radius of 1. So R is 1. So that means 1 unit could be 1 foot, could be 1 inch, 1 centimeter, what have you. So we're dealing with a unit circle where I have a radius of 1. So R is 1 there. Well, a radian is a relationship between circumference of a circle and then the total angle measurement in a circle. How many degrees are in a circle? If you go all the way around, what is that? That's 360 degrees. So that's what a radian is. Well, that means we got to know what circumference is. So off to the side, let's figure out what circumference is. Go back to your geometry days. All right, what do you guys remember for circumference? Remember, that's the distance around the circle, right? What's that distance? You go all the way around. Randy, remember? Yeah, 2 pi times your pirate. R. There we go, 2 pi r, right? Or also known as pi d. Pi times diameter, because 2 times the radius would be the diameter directly across. So very good. So 2 pi r is circumference. And when we plug in r is 1 for a unit circle, we get 2 pi. So a radian represents the circumference around the circle in relationship to how many degrees are in a circle. So if we take 2 pi and divide by 360, we get 1 radian, or 1 rad for short. What's 2 and 360 reduced by? What do you get? Pi over 180. There you go. Reduced by 2. So 1 radian represents pi over 180. Okay, so the relationship to a radian is if you go around a circle, that's the circumference. They're taking that relationship of circumference with the degrees and calling it a radian. Okay. Well, that's our goals for today. Goal number 1 is convert something that's in degrees and get it into radians. Well, if I want to do that, I've got to multiply by pi over 180. So I can either multiply by pi over 180, or this is what I do. I'll take that number and divide by 180 and then put a pi on top. Does the exact same thing. Okay, now you're going to be so good at this that you're going to be able to do this real quick. And we're going to do speed sheets to do it. You guys remember speed sheets back in elementary school where you had like 60 questions and you had to do like 5 times 5 and 5 times 6 and 5 times 7 and 7 times 9, and you had to do all those like really fast, and like you had like a minute to do it, a minute to win it. You guys remember that? Well, we're going to do that with converting degrees to radians, radians to degrees. And that's going to give you an opportunity to earn some extra credit. How's that sound? No, kind of scary. Don't be scared. It's easy. I'll give you like 3 minutes to do 16 of these. Super fast. So let's do this, and you're not going to be able to use a calculator. So the first thing I do, if I have 120 over 180, the first thing I do is I cross out the zeros and make it easy numbers. It's 12 over 18. 12 and 18 have what in common? 6, right? They reduce by 6, so take 12 and divide by 6. That's 2. Take 18, divide by 6. That's 3, and then put a pi on top. We call that 2 pi over 3. And then when you start seeing this over and over, and be like, oh yeah, I remember 120 is 2 pi over 3. Okay. So again, we're going to take 90 and multiply by pi over 180. Or what I do is I'll just take and divide by 180 and put a pi on top. So get rid of the pi. What's 90 divided by 180? Or what's 9 divided by 18? What is that? That's 1/2. And then put a pi on top. 1 times pi is just pi, and then over 2. We get pi over 2. Now, 5 out of 4 of you guys are really bad with fractions. You can just use your calculator. If I have 120 and I divide by 180, you get a decimal, and I math frac. That's 2/3, and then put a pi on top. 90 divided by 180 is 0.5. Oop. 90 divided by 180 is 0.5, math frac. That's 1 pi over 2 if I put a pi on top. Or pi over 2, I prefer. Okay. How we doing? All right, so last one, 45, in this case, negative 45. Go ahead and divide by 180 and put a pi on top. How many times is 45 going to 180? 4 times, so you get 1/4 negative. Put a pi on top, negative 1 times pi is just negative pi. You don't need the 1 anymore. So we should get negative pi over 4. Good stuff? Not too bad? And eventually you start doing that over and over and over, you start seeing how things reduce pretty easily. Okay? So we'll start the speed sheet tomorrow. See how fast you guys are. All right, number 8. Now we're going backwards. We got pi over 6. The idea is we're going to try to convert this radian into degree. Well, if you look at degrees, there is no pi. So what's going to happen is this pi is going to cancel with this pi. We need a pi on the bottom, so they cross out. So that means we need the 180 on top now. So when I convert degrees to radians, multiply by pi over 180. When I go backwards, multiply by 180 over pi so that the pi's disappear. And now I take 180 and divide by 6. Or take 18 and divide by 6. What's 18 divided by 6? 3, and then add the 0, you get 30. Pi over 6 is 30 degrees. All right, so we do it again. We want the pi's to cancel, so I need a pi on the bottom and 180 on top now. So the pi's cross out. And now I got to divide 180 by 4. Now, for some people, that's hard. So we'll take 180 and divide by 2, and then divide by 2 again. That's dividing by 4. What's 180 divided by 2? Is 90, and 90 divided by 2 is 45. Now you just divided by 4. Okay. And now take 3 times 45. You BFS guys should know this, or gals. Put a sewer cap on one side, a sewer cap on the other in the bar. 45 plus 45 plus 45 is how much? 45 times 3 is 135, right? You BFS guys know that, right? Right, should know that. And gals. Well, last but not least, I got negative 2 pi over 3. Well, we already did 2 pi over 3, right? What's 2 pi over 3? Okay, heard it, negative 120. How do you do that? Multiply, so the pi's cancel, and I get 180 on top. The pi's cancel. 180 divided by 3 is 60, and negative 2 times 60 is negative 120. Boom. Okay. Some teachers, when they do the unit circle trig, when they do sine of pi over 4, they want you to leave it in terms of radians. I don't like doing that. I will switch it to degrees every time because I think it makes most sense for you guys to leave things in terms of degrees. And if it's not, then I always convert it into degrees for you guys, or with you guys. Okay, so it makes it a little easier. All right, do you guys have any questions with converting degrees to radians, radians, degrees? All right. I am going to skip over 11 and 12 right now. I want to get back to 13 and 14, some easy stuff. So grab your calculator. We're going to convert degrees, decimal degrees, into what we call degrees, minutes, or seconds, which we call DMS for short. Okay, so this is what DMS looks like. Degrees, tick mark means minutes and 30 seconds. Okay, you have seen this somewhere. Where have you seen something like example 14 before? Where have you seen that? Or maybe you've never seen that. Please tell me you've seen this. Mary? No? Never? Grace? Stuff you put in your calculator. Eventually we're going to put in the calculator. But where outside of math have you seen something like this? Isabel? Yes, latitudes and longitudes, right? You remember seeing that stuff? You go, anybody do geocaching or anything like that? Right? No? Alex has done it? No? In biology class or? Anyways, well, that's what we're going to do, guys, is basically convert things from decimal to degrees like this guy into something that looks like number 14 with degrees, minutes, and seconds. So here we go. I'm going to type this guy in like you have it here. I got 75.255. So 75.255, and then I got to go and find the angle menu. So take a look. Where do you see the word angle on your calculator? Do you see it? Yeah, it's apps. Right next to the math menu is the apps menu. So if you press second apps, you'll see the angle menu. Okay. And we want to convert this into DMS. So I go down to number 4 and press enter. Does it all for me. So I've got 75 degrees. I've got 15 minutes and 18 seconds. Double tick mark. Okay, basically what they're doing is they're taking this decimal, 0.255, and they're converting that into minutes. Okay, how many minutes are in an hour? 60. Well, there's 60 minutes in a degree. So if you multiply by 60, that's where the 15 comes in. So we've converted this into minutes. I get 15.3 minutes, and now I'm going to take that decimal 0.3 and multiply that by 60 to convert that into seconds. So that's where they get the 18 seconds from. Now, you do not have to do that yourself. The calculator does it for you. So again, type in the decimal, find your angle menu, DMS it. Degrees, minutes, and seconds. Okay? Well, you also have to be able to go backwards. So this is in degrees, minutes, and seconds. Now we want the decimal of that. Okay, so here we go. How do you do that? Well, I'm going to type it in like I see it. So I got 100. I need the degree symbol. So I press second apps. That's number 1. Then I need 20. I need the little tick mark for minutes. So second apps. Number 2 is the little tick mark. And then 30, and then if you look in the angle menu, you will not see the double tick mark. Why? I don't know. I talked to my buddies at Texas Instrument, and Jim said he didn't know why double tick mark's not in there. And I said maybe in the next update we could get that. And he said, okay, Chris, we'll get that. So what you have to do is you got to press alpha plus. So alpha plus will give you the double tick mark. So alpha is the green button for me. So alpha is underneath second, and then the plus, and you see the double tick mark pop up. You guys see that? Why is it there? Jim had no idea, but that's what we got. Press enter, and I got 100.3417 if I round, and that's degrees. So you guys should be able to convert from decimal degrees to degrees, minutes, and seconds, and back to decimal degrees. So just type it in like you see it, and then press enter, and it should work out. Any questions, y'all? Okay, that's pretty easy, right? All right. Last but not least, coming back to number 11 and 12. Okay, arc length. If we have a central angle here in our little circle, back in the day, they'd say, hey, can you find this little fraction of the circumference? And back in geometry, we would have to figure out what this angle was. We'll call it theta. And usually it was like 30 degrees or 90 degrees or whatever. We took that, we divided by 360, and that gave me what fraction of the circle it was, right? So if this was 90, what's 90 divided by 360? What is that? That's a fourth of the circle, isn't it? That's 90. That's a fourth. So then we would take that 1/4 times the circumference to get that fourth of the circumference. Okay? Well, now we don't have to do that. We can just use this little formula. S is for arc length equals R, your radius, and then times theta. But theta has to be in radians. If it's not in radians, we got to convert it. Okay? So let's try this. We're just going to do arc length for this one here, and we'll do area of a sector for this one just to make it easy. Okay, so for number 11, I've got R equals 3 centimeters, and theta is pi over 3. And I'm going to plug into R times theta. Now, we have R. What's R? 3. Do we have theta in radians? It's either going to say it's in radians or it's going to have a pi in it. So is this in radians? You betcha. It has a pi over 3, so it is pi over 3, and that's in radians. If you see a little decimal, a little degree symbol, like if you saw that this was 60 degrees, then we got to convert that into pi over 3. Okay? So we simplify. I got 3 times pi over 3. What happens? Yeah, these guys karate chop, right? One's on top, one's on the bottom. I get pi. If you want the approximation for arc length, use your calculator, 3.14, and we're in centimeters. Okay, so anytime you guys are doing arc length, let me zoom out just a touch here. Arc length is units, because it's a distance. We're trying to find a portion of your circumference. All right, any questions, y'all? Area of a sector. Back in geometry, we had to figure out what this angle was, that central angle. And we would take that angle, we would divide by 360, and then we would multiply that by area, pi r squared. Well, same thing, but we don't have to do that if theta is in radians. So again, theta has to be in radians. If it's not in radians, I got to do it. I got to convert it. So we're going to use this formula, A equals 1/2 r squared theta. All right, so I've got 1/2 r squared theta. I'll just write the formula for you guys. So I got 1/2 r squared theta. I got 1/2 r is 8 squared, and then theta, is that in radians? Does it say like 1.7 radians, or does it have a pi in it? Yes, right? It has a pi in it, so that is in radians. And then we do some simplifying. When you simplify, please excuse my dear Aunt Sally. Okay, we got to do our exponents first. So don't take 8 and divide by 2 and then square it. We got to square it first. What's 8 squared, y'all? 64. Got to do that first. Okay. Now again, if you are bad with fractions, you could go through and take 1/2 times 64 times 3/4 and then multiply by pi. I usually just do this in my head. What's 64 divided by 2? That's 32. Okay. Then I have 32 divided by 4. That's 8. Right? So now I have 1 times 8 times 3. That's 24, and then pi. Now that's the exact value. So if I want exact value, that would be millimeters squared. If they want the approximation, then I would do that in my calculator. So I got 24 pi. That is second raised to for pi. So above the division sign is the raised to button right there. So 24 pi, that gives me approximately 75 point, we'll say 4 millimeters squared. So you want the approximation. Okay. Now, some people will use 3.14. That's pretty close, but you'll see if you're using 3.14, it's a little bit off. It's not quite exact. So if you had to do 2 decimal places in my math lab, that's going to be wrong. Okay, so make sure you're using the pi symbol unless they say otherwise. Again, reminder, area is always units squared. And arc length is always units. Okay. All right, ladies and gentlemen, that was a good start. You guys have my math lab. Do you guys have any questions for me?